Alright, in this video, I think we're going to be talking a little bit about the differences among different types of data which we can use and manipulate in GIS. And so we've got this vectors and rasters and tables, and many of you may have heard these terms before, but we're going to try to do our best to define them a little bit more tightly and give some good examples of what they are. So vector data. So a vector data, it's coordinate-based data, and represents geographic features as points, lines, and polygons. And vector data is very interesting because there is no fuzziness associated with vector data. It's very exact, and I'll show you some examples of what I mean. So this is an example of points. So points are vector data. Okay, and for points, it's sort of zero dimensionality. It's only a property of location. We're looking at this in XY space, but we could add another axis here to give us into three-dimensional space. We can see if I want to locate point 1, well, that has an x coordinate. If we look, if this is the x-axis, and then this is the y-axis. So point 1 is a coordinate of 2, 1, 2, and 9 up here. So here's point number 1, right? So everybody, and we can sort of get these guys. It's exactly at this point. It's at point 2, 9, and that's very powerful information for us, points. Lines are curves or connections of straight line segments, which are, we can look at line number 1 here, right? And so it is made up of a sort of a beginning node and an ending node, right? And so the beginning node is node 11 and the ending node is node 12. And node 11 has these coordinates, right? So it would be 0 and 9 or whatever the case may be. And the end node is at 2, 9, right? And that's really, so this is how these guys are built up. They're exact. And if we keep on zooming in, they will remain very clean to our eyes and with perfect edges and so on. And we can make polygons from collections of these arcs or these lines, right? So polygon number 101, which is over here, is made up of these different lines. Line 1, line 4, and line 6. All together that makes up polygon 101. And these are the, if we break down arc 1, what is it made up of? Well, it's made up of these guys, right? So here to here, this is line 1, and so on. There's also some interesting things going on here in that we can think about these arcs, and we can think about sort of what's on either side of these arcs. So for arc number 1, which is this length right here, right? On the right-hand side, if the arrows give us some sense of direction here, right? So arc 1 runs this way to here. On the right-hand side, we're dealing with polygon 101. On the left-hand side of this first arc, we're dealing with polygon 100, which is sort of, here's polygon 104, right? We can see some interesting things about line 7. On the right-hand side of arc number 7, we're dealing with polygon 104. On the left-hand side, we're dealing with polygon 102. Okay, so I said before that these are sort of exact elements, right? And topology is an interesting word. Topology is talking about, or it's a study of geometric objects, and it's those properties of these objects which are invariant. They don't change under different transformations like stretching or bending. You can imagine you've got a rubber donut, you stretch it out, you bend it back, you twist it, it still has the shape of a donut, right? And so topology is those properties that are invariant over those types of transformations. And these arrangements, they constrain how, it can also mean, a secondary definition of topology is the arrangement that constrains how point, line, and polygon features share geometry. This is an example of a map in the Boston area, sort of the metro map in the Boston area, right? And this is where the stations are, those little dots, where they actually are in geographic space, right? This map, if you're not from that area, it looks a little bit confusing, right? To try to find out and figure out which, green station you want to end up with, it's a little bit problematic. If we stretch the data out and instead of being in geographic coordinates, we're over grid coordinates, this is a lot easier to understand, right? And the relative position of this station here relative to the station on either side of it on this sort of green line, that hasn't changed, but what has changed is, we've stretched it out, we've distorted the spacing and so on. But in doing that, we've made a much more clear visual representation of that system. And I would argue that even if you're from that area, I would still prefer to look at this map in some cases than this map. If I'm really worried about, geographic space, this map is good. If I'm navigating through the city and I just want to, meet my friends and they're on the gray line at this particular point, I don't care as much. I want to know how many subway lines and so on. Anyway, so that's an example of topology, how we can sort of change things and see what happens. This is an example in the GIS sense of topological editing, where there's some rules, right? Where different polygons that are right next to each other, they should not overlap generally. They shouldn't have any gaps. If we're talking about, like for a county, right? The planning department of Hawaii County, and they've got little TMK parcels or so on. If there's a gap, right, between two different TMK parcels, that's sort of problematic, right? Or if they overlap and you say, oh, I own this property, well, and the other guy said, oh, I own this property, and there's an overlap here, right? Nobody likes that, right? So voting districts, census tracts, all these guys, right? So there needs to be some control here, and if we talk a little bit about geodatabases, they're actually really good for this type of editing. If we have individual independent shapefiles and we change one, that doesn't necessarily link with the one next to it, and so we can get these sort of gaps and so on. So when you're editing, and this is some of the things that we'll do in the future, editing different shapefiles and so on, it's easier to move this line once than to move this line and then to move this line on this polygon, right? So it's easier to just do one move and everything knows what the other guy is sitting at. And I'm gonna, at this point, I will stop this first video and then we'll pick it up next time with tins.